Hey guys, Mr. Backerberg here. In this video, we're going to look at factoring with real number coefficients. So when we're talking about the factors of a polynomial function with real number coefficients, every single polynomial function that has real number coefficients can be written as a product of linear factors and irreducible quadratic factors, and each one of those will have real number coefficients. So as we take a look at this example, I want to take this function and write it as a product of linear factors and irreducible quadratic factors that all have real number coefficients. And what I want to start with first is coming up with a list of possible zeros by using the rational zero theorem. So for the numbers in the numerator, I'm going to look at the factors of the constant term on the back end. So we've got 16. So the factors would be 1 and 16, 2 and 8, and also 4. But we have to remember the positive and negative versions of all of those. And then for the numbers in the denominator, I'm going to look at my leading coefficient, so in this case the 3, and the factors of 3 are 1 and 3, but again considering both the positive and negative versions of those. Now I'm going to take these numerator values and denominator values and start combining them to build my list of possible rational zeros. So I'm going to start by taking all of these values in the numerator and putting them over 1. So you'd get positive or negative 1, positive or negative 2, 4, 8, and also 16. Now I'm going to take these numerator values and put them over the 3 as well. So we get plus or minus 1/3, plus or minus 2/3, 4/3, 8/3, and also 16/3. So we've got a big long list of possible rational zeros. So to help me narrow this down, I'm actually going to pick an approximate zero off of the graph of my function and then use synthetic division to prove that it is a zero of my function. And doing that synthetic division is also going to help me start breaking this polynomial down. So I've got my function typed into my calculator. I'm going to hit graph to help me find some of the zeros. Now we can see that none of these zeros are happening at nice integer values. So I'm going to focus on this one that's happening at just a little bit short of 1. So we can see that it's more than halfway but less than 1. So if we're thinking about our list of possible zeros that we just made, this is probably 2/3. So what I'm going to do is run synthetic division using that 2/3 to prove that 2/3 is a zero of this function and start factoring this function out. So I went ahead and set up my synthetic division. I'm going to drop down the 3. 3 times 2/3 is 2. Negative 2 plus 2 is 0. 0 times 2/3 is 0. 6 plus 0 is 6. 6 times 2/3 is 4. Negative 4 plus 4 is 0. 0 times 2/3 is 0. Plus negative 24 is negative 24. And negative 24 times 2/3 is negative 16. So we get a 0 remainder, which proves that 2/3 is a zero of our function. Now if we're thinking about the factors, if 2/3 is a 0, that means that x minus 2/3 is a factor of our function. Now what I want to do with the leftover stuff down here is I'm actually going to put the x's back in. We started with a quintic function, a power of 5. We did one round of synthetic division, so I'm going to have to drop the power by 1. So this 3 is really on an x to the 4th. This 0 would be on an x cubed. The 6 is on an x squared. This 0 would be on a plain x, and then this negative 24 on the back end is my constant term. Now what I can actually do with this is all of these terms are divisible by 3. So I'm going to GCF factor out a 3. So that'll leave me with x to the 4th plus 2x squared minus 8. And now I can actually do a little bit more factoring with this. If I think about it like sum and product factoring, to multiply to x to the 4th, I'm going to take x squared and x squared. And then I would have to think about things that multiply together to give me negative 8, but add up to 2. So this is going to be x squared plus 4 and x squared minus 2. Now I'm not just going to leave this 3 hanging out in here. What I'm actually going to do is take the 3 and distribute it into this first factor, because when I take the 2/3 times this 3, that's going to help me cancel out some of the fractions in there. So 3 times x will give me 3x, and 3 times negative 2/3 is going to be negative 2. Now, as I'm looking at these factors on the back end that we just got from factoring out that quartic function, I want to check to see if I can break them down any further. I want to see if any of these quadratics are reducible. So I'm going to first look at the x squared minus 2. If I were to think about finding the zeros there, I would take this factor and set it equal to 0. I would add the 2 over to the other side, so I would get x squared equals 2, and then I could safely square root both sides. So I would get zeros at x equals positive or negative root 2. So if those are the zeros, then I can think about the factors in a linear sense as being x minus the square root of 2 and also x plus the square root of 2. Now we've still got that 3x minus 2 factor from earlier, but the last thing I want to look at is that x squared plus 4 to see if that's a reducible quadratic. So if I took x squared plus 4 and set that equal to 0, I would subtract the 4 over to the other side, so I would have x squared equals negative 4. Now when I try to square root this x squared, I end up trying to square root a negative 4, which tells me that this quadratic term is irreducible. We cannot break it down any further, so I'm going to leave the x squared plus 4 alone. So this stuff right here is my polynomial function rewritten as a product of 3 linear factors and 1 irreducible quadratic factor. That's going to be it for this video. Thanks for watching.